All right, this is your 2.3 notes. So for this one, we're looking at domain and range. So it says find the domain and range of a function whose graph is shown below. So there's going to be two ways you can write your domains and or ranges. So what you want to remember first is your domains is the set of x, your range is the set of y. Okay, so basically by writing out the domain and range, you're letting me know what are x and y allowed to do. So for this first one, this is just a set of fixed points for your function. Anytime you're doing domain and range with a set of fixed points, the only way you can really write that answer is to use what's called set notation. So for my domain, you can write the word domain, you can just use the D. I always put a little subscript F to show which function it is I'm dealing with. And then for set notation, it's inside your set braces, so I call it open squiggle. And then we say X such that, so the way this starting part here is read, highlighted, fill green. So that is read as the set of all x such that. So what you're saying is your domain is allowed to be the set of all x values such that, and then you tell me whatever it is, restrictions have to be in place for x. So in this case, when we have a set of just fixed points, you just list all of the x values that x is allowed to take on. So I'm just going to kind of go from left to right. So the set of all x such that x is only allowed to equal specific values since we only have points. First x value I see I'm allowed to equal is -5, and I just separate each by a comma. Then if I keep moving to the right, the next point I see that x can take on is 1, comma. Keep moving, then we hit the x value 3, comma, and finally the x value 4, and that is the end of the x's we're allowed to take on. So then you close your set or close your squiggle. So the domain of f is the set of all x such that x can equal -5 or 1 or 3 or 4. There are no dots anywhere else. For your range, we use a capital R to signify the range. So the range of f, again, we have to use set notation because it's just a fixed set of a bunch of points. So open squiggle, y such that y equals, and then we're just going to list the y value. So I'm going to go from bottom to top since our y-axis runs vertically. So the smallest y value I see is -5, comma, moving up. I see the y value 0, comma, y value of 1, and finally a y value of 3. That is the end, so then I close my squiggle. All right, the next one. For the function f represented below, determine each of the following. So this is the number in the range that is paired with -2 from the domain. So that sentence is worded a little bit weird. What you would typically just be asked is, what is f of -2? So this right here. So remember, when you're saying what is f of -2, I want to know what is y when x is sitting on -2. So you are looking for the y value because f of something is the fancy label for y. What is y when x equals -2? So f of -2, I did not leave a lot of room here. I guess we'll go down here, A. So f of -2 is, so what I am looking for is where x equals -2. So I'm just going to label that here. So if I go to my graph, x equals -2 on my x-axis. Here is the x value -2, so I go up and I find my intersection. I'm just going to be right here. So I'm looking for the y value of that point, which is 3. So f of -2 is the y value 3. All right, for B, the domain of f. So remember, domain is the set of all x's. So difference in this one versus the last one. The last one was a set of fixed points. This one is an actual line, or a chunk of a line. So, or a curvy line. So we can't just list everything because technically there's infinitely many points in here. So what we're going to use here is there's two ways you could write this. When we have actual typical functions where it's a part of a line or a full line, we're going to use set notation or interval notation. So for B, I'll start with the set since we've already done one of those. So the domain of F is going to be all of the x values such that, so because we cannot list them, it's an infinite set. We want to find the smallest x value we are allowed to take on and the largest x value we are allowed to take on. So that means looking from left to right on my graph. So if I've got like a vertical line here, trying to locate the smallest and largest x, the x-axis runs left to right. So the smallest is going to be on the left, the biggest is going to be on the right. So if I come over here, that looks like the smallest value is -5. So x equals -5. It also has a closed circle on it. If you look at that endpoint, it is closed. When it is closed, that means it is included. So closed or included. And then we move our vertical line over, and I am looking for the largest x value I'm allowed to take on. Everything in the middle is covered. So over here, it looks like the largest is 3. So this will be x equals 3. And if I look at my point, it is also closed, so it is also included. Remember, when it's open, it is considered to be excluded. So this one is also closed or included. So I can take on any value, any x value in between those two numbers, and I can take on both the -5 and the 3 because of the closed circles there. So to get that written in the proper notation, we're going to use an inequality. So the smallest x value we can take on is -5, and I can take on any x value in between up to and including the 3. So because both of those had closed circles, notice we do have the underline on our inequality symbols. Anytime the points are closed, you will have an underline. Anytime the points are open, you will omit that underline and just do the strictly less than or the strictly greater than. If we want to change this over, so I said there's two notations. There's the set notation and there is the interval notation. So this would be our set notation. For the interval notation, we'll label them both so you know which is which. So this was set, and then this one's going to be interval. Interval notation uses what are called parentheses and or brackets to write out the function's domain and or range. So basically with interval notation, you are going to translate that inequality that's in the back of your set notation to an interval. Interval notation is smaller number, comma, larger number. So I know that the -5 is my smaller number. I know that the 3 is my larger number, and then you're going on the outside and placing either parentheses or brackets. So because the inequality symbol associated with the -5 has the bar on it, that translates to an inclusion. Therefore, we are going to put a bracket outside. A bracket means the number is included. When I look at the number, the inequality symbol associated with the 3, that symbol is also included because it does have the bar on there as well, which means I am also going to use a bracket here. So this tells us I can be anywhere from -5 up to 3, including both of them and everything in between. And again, if they are open circles, those brackets will be swapped out with parentheses because parentheses imply something is excluded. All right, for C, the number in the domain that is paired with 6 in the range. Oops. Number in the domain that is paired with 6 in the range. There's a little typo there. So let's see which. Yeah, that's supposed to be a 3. That's oops. Let's whoopsies, scribble that out, and let's turn that into a 3. Oops, I'll get that fixed on your copy of the notes. All right. So difference here is we're looking for the number in the domain, which means we're looking for x, given the number in the range. So right here, this right here is our y value. So I'm going to copy it down here below because I don't have a whole lot of room. Okay, so we're going to scoochy this over. I'm going to scooch this over. And I'm going to bring my arrow back over here so that we can see it. All right, for C, set them up side by side. So for C, we know f of x equals 3. So that is telling us that y equals 3. So not x, y. So what we're looking for is the x value where that happens. So y equals 3. So here is the y value 3. So if I look right here, get that to zoom in, I'm not quite at 3, but if I look here, I am sitting directly on 3. Whoops, my arrow didn't cooperate. Right there. So when y is 3, we follow and connect down this time to our x-axis. X turns out to be -2. So f of -2 equals 3. So our x value is -2. This is what we're looking for. So it could go either way. So make sure you pay attention to whether you are given the x value and ask for y, or given the y value and asked for x. All right, for D, we are looking for the range. So the range is your y-axis where you are allowed to be. So again, we're going to do it both ways, set and interval. So R of f, open squiggle, y such that. So this time we are looking at the bottom and the top of our x-axis. I'm going to use dark blue here. So I'm not looking left to right this time. I'm going to draw a horizontal line. I am looking from the bottom to the top. So if I start moving this horizontal line up, the first y value I hit, notice it's not on the endpoint, it is right here. The first y value we hit is -1. So right here, this is where y equals -1. And because the graph does touch there, that is considered to be closed, even though it doesn't show a closed circle, the graph hits. So that is the same thing as included. All right, then we keep moving our horizontal line up, and I'm looking for the biggest y value. So I'm moving up, we're hitting all of these y's in between. Keep on going, the graph goes all the way up, and that is going to be a y value of 7. So this right here does occur at an endpoint. So right there, our biggest y equals 7, and because of the closed circle, that is also included. So with the upper bound, we didn't actually hit the graph, it was on an endpoint, so you're still looking at that open versus closed. Get rid of my line. So y can take on anything in between -1 up to 7, including both of them. So for my inequality, -1 less than or equal to, make sure you use a y, less than or equal to 7, and then close your squiggle. For the interval notation equivalent, so just like domain, you can write set or interval. Range, you can also write set or interval. So for your interval notation, you're just taking that inequality, so smallest left, biggest right, and transitioning it over to the interval notation. So because the inequality symbol on the left here has the bar on it, we're going to include the -1. And then the inequality symbol on the right also has the bar on it. We are also going to include the 7. So if the graph hits, it's included. If it's on a closed circle, it's also included. So as far as writing an interval notation, it could be a combination of parentheses and or brackets, just depending on how the endpoints occur. Anything as an open circle, and when I say open circle, what you would see is, so like on this point right here, where that clearly is a closed circle, if it was open, this is what you would see. It would look like a hollow point. In that case, you would drop the bar on your inequality, or you would change out the bracket on your interval to a parenthesis. All right, next one. So next thing we're looking at is algebraic domain. So again, make sure you read through your notes. So find the domain of each of the following functions. You may write your answer in set or interval notation. So when you're doing algebraic domains, you are not intended in any way, shape, or form to try to sketch the graph. We have not discussed how to sketch any of these graphs. Therefore, you are not expected to know that right now. So the other thing you see is you can write your answer in set or interval notation. We will write them in both just for practice. All right. So for A, so there are 3 things that cause issues with denominators. Go through them one at a time. So if I'm looking at this, I'm going to go, do I have a denominator? Yes. Whenever you have a denominator, we are not allowed to divide by 0, which means whatever is in your denominator is not allowed to equal 0. So I am going to pull what is in my denominator exactly as it's given, which is x minus 8, and say my denominator is not allowed to equal 0. Solving a not equal to works just like solving an equal to sign. So I would add 8 to both sides. And we get x does not equal 8. So that is going to be the restriction on your domain. So we know what needs to happen. Now we just need to get it written in the appropriate set or interval notation, and we're going to do both. So the domain, this is the function f, so I'm going to put a d sub f, is the set of all x such that, so when you're doing the set notation with a value you're not allowed to equal, you simply just copy it in. X cannot equal 8. Set of all x such that x cannot be 8. It can be any other number, it just can't be 8. For interval notation. So interval notation uses your parentheses and or brackets. So we need an interval that represents being on any number, any real number, except the number 8. So that means as far as below 8, I can go as low as I want, which would be negative infinity. Negative infinity is a symbol. It is not a concrete number. Therefore, it is never included. It is always excluded. So your infinities always get a parenthesis. I can go as high as I want, meaning all the way to positive infinity. And again, infinity is going to get that parenthesis every single time. The only thing I am not allowed to be on is the number 8. So I am simply going to stop my intervals at 8 and exclude 8 on both of them and hop over. Anytime we have multiple intervals, we put the symbol U in the middle, which is your union. That means or. So you're saying you can be in this interval below 8 or in the interval above 8. Make sure you exclude both of them here. So I've got the exclusion, which is the parenthesis, on both. So you exclude in both cases. Otherwise, that means you're on 8. So notation wise, you can write it either way. Just make sure you read the directions so you know which way it needs to be written. All right, for the next one, we're going to scoochie just a little. Nope, that's not what I want you to do. Go back up where you were. Maybe. Here we go. All right, this is what I was trying to do. Drag it a little bit. Let's get a little separation. All right, for B, one thing at a time. And you go, okay, here's my function. Do you have a denominator? There is no denominator here. So we don't even need to worry about restricting we don't have to worry about the division by 0. Second issue is square rooting is about all you're going to see here, but it's technically an even root. So what you're looking for is a square root symbol. I do not have a square root symbol anywhere in here, therefore I don't need to worry about it. The third restriction we will cover in a totally separate chapter, but I like to go ahead and list it so that you at least have been hearing it, is any logs. So logs are log or ln printed in your function. I do not see the letters log or the letters ln. Therefore, I have no denominator, I have no square root, and I have no logs. If you say no, 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 you have no problem with your domain. So there are no restrictions on this domain. There's no denominator, there is no square root, and there is no log. When there are no restrictions, your domain is all real numbers. So as far as ways to write that, there's a couple of different ways to write that. For my set notation, I always just use the double bar R. The double bar R represents the set of real numbers. So this right here is defined as the set of real numbers. So that's usually the way I will write my domain. In many textbooks, you're taught to use the proper set notation with the squiggles. So we would just simply say x such that you might use the x is an element of the real numbers. Some textbooks, well, we'll leave this here just so you can see the different representations. Other textbooks will still make you use the inequality, so x such that it would just be from negative infinity to positive infinity. So I don't care which way you write it. I did forget the bar on my R. They're all the same thing. So you can choose if that bottom one's what you've been taught, that's perfectly fine. I don't care which one you use. For interval notation for all real numbers is no restriction whatsoever. So it's just basically saying I can go from negative to positive infinity. And remember, your infinities are always parentheses. Never bracket an infinity symbol. So you can write it whichever way you want. Interval notation, there's only one way to write it. Sets where you're going to have some choices. All right, next. All right, so worry about one restriction at a time. So if I look at this function here for C, do you have a denominator? Yes. Your denominator is 3x plus 1. Denominators are not allowed to equal 0. So we're going to pull our denominator in its entirety. I could care less about anything outside of the denominator. I'm just concerned with that denominator. My denominator, 3x plus 1, is not allowed to equal 0 ever. So then we go through the algebra. I'm going to move my 1 over. So we get 3x cannot equal negative 1. I need to divide the 3 off. So I get x cannot equal negative 1/3. Do not write it as a decimal. Leave it as a fraction. Okay. Negative 0.3 is not negative 1/3. Negative 1/3 is that repeating decimal. Leave everything as a fraction form unless it states otherwise. All right. Notations. I'm going to write it both again. Set and interval. So our set notation, this is still the function f. So the domain of f is open squiggle, x such that. Restriction on x is that it cannot be negative 1/3. So I'm just going to copy directly. X cannot equal negative 1/3, and I'm going to close my squiggle. For interval notation, domain of f, I can be on any real number I want except negative 1/3. So that means you can go as small as you want, parenthesis. You may go as large as you want, parenthesis. You just cannot stay on negative 1/3. So we're going to hop over it. So I'm going to take a pit stop at negative 1/3. I am going to exclude it. I'm going to use my union symbol because I've got two separate intervals here. I am going to hop over the 1/3 on this interval as well, always excluded. So again, you can write it whichever notation you want. Just read to make sure you answer correctly. All right, for D, go through your restriction one at a time. So if I'm looking at the function D, do you have a denominator? No, I don't need to worry about it. Nothing, no restriction because there is no denominator. Even root, square root. There is no square root symbol. Remember, your square root symbol is something like this. We're not worried about those yet, but you still want to be mentioning them. Third case, also not worried about it yet, but we're still going to check log. I do not see a log written anywhere. So no denominator, no square root, no log, no restriction. If it's no restriction. So no restriction for your domain. Again, notation of choice. I like the double bar R because that's the shortest thing to write. If you prefer, I know a lot of the books are x such that XER, which is x is an element of the real numbers, perfectly fine as well. For the interval notation, no restriction means as small as you want to go, always exclude. As large as you want to go, always exclude. Never put your brackets on your infinities. So here's your zoomed out version, I think, of this example, in case you need to freeze it to look at. And then the others are the you try it's. So everything is filled out on the completed notes for the you try it's if you want to look those over and or try them yourself and check them with the key.